Good morning. Welcome to the ongoing online course on Engineering or Architectural Graphics Part 2. And in this course, we have been studying about isometric and axonometric projections. This is the last lecture of this course and we are learning about axonometric projections in this particular week. We have already seen how to draw different 2D and 3D objects in isometric and axonometric both. And in this last lecture, I am going to take up some more examples of combinations of solids or intersections of solids, which is what we are going to see. Now, so far what we have done in axonometric is that we have seen the objects in isolation, freestanding objects in certain conditions. But now what we are going to see is how these solids would appear if they are connected, if they are combined or if they are intersecting each other in axonometric. Okay. So, let us start by taking few more examples, and as I said, I have tried to keep the same examples as we used for isometric, so that we can very clearly see what we are going to, what is the difference between isometric and axonometric. Now, this is the plan, this is the elevation which is given and this is the side view. I am going to start by taking the plan by drawing it. That is the simple thing which we are going to do. So, if you look at this particular object and I will start by taking the axis here. So, if I draw this plan here, this is how it will look like. So, when I repeatedly say that when you draw it, please draw it properly. I am drawing it without a grid, so the lines look little confusing at times. This is approximately how this is going to look like. This does not look like a square, but it is a square here in the original object. Okay. So, this is what we saw in the plan. Now, we will just take the heights and see how we derive the object. So, if you look at this 1, 2, 3 and 4 here. So, 4 is at the bottom. Okay. So, maybe we can start with this one here, T is here and V is here. So, this is at the bottom, which is here, these 2 points, and then S here at the back and T. So, all these 4 points are in the bottom. Now, we give them the heights. So, we can see where these heights are coming. 40 here for this one. So, okay, I will reduce the height so that we can actually arrive at all the 4 points. So, this is what you will see, exactly the same parallel surface as in the bottom will appear in the top by taking the heights for all the 4 points. So, this is what we have done. Now, there is another cuboid which is intersecting this vertically kept cuboid. So, now what we have to arrive at these, this is M2. So, M2 in plan is here and there is certain height to M2, which is what we will see here appearing. Okay. Now, here this is M1. M1 has certain height which we will see again vertically, which is what we will see here. There is another point which is M3, which is here, again it is coming on the same line because this is inclined at 45 degrees. So, we will see this M3 coming at the same height as this, but since it is slightly behind, and if you see this, you can join this as a line and when you look at these will also be joining in a parallel line like this. So, this is where the other point is going to be, and then we have the fourth point which is going to come below this, which is M4, which is again below this, and if you look at this and you raise this one here, so you will get a height somewhere here. So, what we will see from here is that there is a point which is raised to this height, then we draw this, okay. M2 which is again above this, this is what you see here. The other two dimensions go at the back, but now we also have these points 1, 2 and 3 and 4. So, we raise them. So, whatever heights you are getting here, now this is the height at which it is intersecting, and if you draw it parallel, this is where we will get our point 2, and right below this on the same axis is where the point 4 is coming, and this is 1 here which is coming on a line parallel to this. So, if you draw a line parallel to this and take it vertically up, this is where the point 1 is coming, and I can take a line parallel to this and on this. So, from this side you will see that we will actually get a square, a full square, but when it goes and meets this solid, it becomes skewed like this, and behind it we won't see, and there is a certain height. Okay, so I should increase this height because initially so I will draw only the part which is now visible. Okay. So, just to make things clear, I am erasing these, and this I have arrived at by just taking the heights, as I said. So, I am just drawing what we will see in axonometric. I have drawn only the half of it. I do not even have to visualize. Now, you can very simply look at this object and see that there is a solid, a cuboid, which is going and penetrating this solid, which is another cuboid, and the one which is penetrating, this one here, has an axis which is parallel to HP and VP, and the one which is standing has an axis which is perpendicular to HP and parallel to VP. This being the reference plane, you can very easily see what is conveyed from this object into an axonometric. That is what we are seeing here. The simple thing which we did was we just took the heights from the plan which was here somewhere. This is what we did, and which is exactly the same thing which you can again do towards the back side, and you will get a complete solid. That is how we can draw axonometric views for any combination of objects or any intersecting solids. Let us look at some more examples, and all I am doing here is repeating the methodology and telling you how just by following the methodology you will arrive at the final axonometrics. Now, here we have two cylinders which are intersecting, and they are coming and joining together at right angles. Now, if I were to, this is at 45 degrees because these are same solids of the same radius, same diameter, same sizes. So, if they will join, this will be at 45 degree, and now if I rotate it like this, which is how we usually do, we will just see a straight line and all the 12 points lined up on that, and we will not see anything. So, instead of that, instead of having my x axis like this, I will have my axis like this. So, the angles remain the same, but I am just rotating it like this and see what happens. So, I have slightly rotated my axis to the other side. This is what my axis now is. So, this angle remains 90° and the vertical axis remains vertical. So, when I rotate it like this, what I will see is that this line, so this is the plan which I have to draw, this line will become parallel in axono. So, it is not parallel, it is making an angle of 45° in the actual position, and it will now be seen as a straight line. Okay. And now I will draw the rest of the plan like this. So, this is the plan that I am talking about. Now, I have 12 different points here. Okay. So, these are the 12 different points and I have their heights here, which is the same height as the 12 points on this circle, which is now here. So, what I will do, I will just take the intersection first. Okay. So, there were these 12 points which we can get. This is P4, so approximately like this, and now we have to give them the heights. So, this is where the center is going to come. Now, raise these heights. It is going to be symmetric on both the sides. It does not appear to be symmetric right now, but it will be symmetric when you draw it technically. Okay. This is the shape that we are going to get when we join all these 12 points, and it is going to be a regular ellipse. Okay. This is what you will see, but this is not what we are going to be seeing actually. What we are also going to be seeing is the circle here. So, we have a circle which will be drawn here. This is the circle which will actually be seen here in the front. This is also vertical, perpendicular to HP. This is also vertical, which is perpendicular to HP, and there is another circle at the back. Which is again perpendicular to HP. So, all three are perpendicular to HP, and now we have to join them. How will we join them? So, we have to draw tangents between these two, which is how they are going to be joining. But remember that these are more or less going to be, it goes below, and this is what we are going to be seeing when we join this. Now, if I darken it, then you will probably be able to make a better sense of it. This is what we see at the back, the line which is parallel, this one here. And here at this level, we will be actually seeing this curve coming. That is how you will actually be seeing this combination of two cylinders which are welded, joined at this level, and this is the dotted, the hidden line which is going to go behind. Now, if you can see very clearly, this ellipse is actually the true shape of this intersection, where these two solids are coming and intersecting each other. So, this ellipse is actually going to be the true shape. So, because very simply, if you see, when we rotate it, this is going to be seen in its actual dimension. It is going to become parallel if the reference plane remains the same. So, we just rotated it, but actually the reference plane is now this. This is our reference plane. And now, if you see, you can actually see how these two cylinders are coming together and joining. Okay. So, if you were wondering why I just dropped, this is where it was going to join behind it. It will not just come and join like this, this is going to continue, and this one is actually going behind and it is at a lower level. That is why we just left it abrupt, and this is what your object is going to be. Again, the same procedure which I have been reiterating is that you draw the plan first and then you take the heights for all the points which are there, and very simply you will arrive at the axonometric without making any mistake. You do not have to worry whether you understand it in the first place or not. The only thing you have to be very careful about is the height that you are measuring is for the same point which is drawn here in the plan. So, for the same point you have to ascertain that this is the height and then start joining the points as they were seen in the orthographic projections. Let us look at certain other examples of common objects which will make things clearer to you. Very simply, I start by drawing the plan, which is a simple circle. This is what this is the outer circle which is seen here, and at this level, where this is just for reference that this inner circle has been drawn, but it is not a hollow. So, this is a reference circle and we have a square which is inscribed in this circle, and we have 4 squares for the legs coming, which is what is drawn in the plan. So, this is what we have as a plan, and all we need to do right now is give them certain heights. So, we have this height, we also have the thickness given, certain thickness, and all we have to do is raise them. We know this is a simple circle. At that height also it is going to be the same circle. Sorry. So, this is the circle that we are looking at. We know what is the height of it, the thickness of it. Draw another circle, we will get the bottom of it, and now we have to just raise the height. In the plan this remains in the same place, but what we will do is we will just raise the height to whatever this height is and draw. Some portion will go to the back of it, at the back of this circular plate which is on the top, and some of it will be seen in the front. So, what I am drawing right now is only the portion which is seen in the front, and some part is already hidden at the back. Now, since I was not measuring properly, this angle probably is not 45, you can very clearly see. If it would be 45 and if it was right behind each other, when you rotate it by 45, these two will be in the same line and we would not be able to see this leg in the of the stool in the back. So, now if I have to darken this one, rather I would erase the ones which we have in the bottom to give you a better picture. So, I am just removing the extra construction lines to make things easier for you to visualize. That is what approximately this tool is going to look like. A circle in the top, part of the circle in the bottom of the same sheet, circular sheet on the top, and apparently 3 legs would be visible, but due to the error in picking the angles, we are seeing here all the 4 legs. So, I will anyways draw it, but when you will draw it, you will realize that this will not be seen. This is simply how we will draw axonometric, and it actually gives a very clear, fair idea of how this object looks like. We could have done it in isometric also, which was also true, which was also correct, but then for that we would have had to measure the dimensions every time. Here all you can simply do is pick this, rotate it by 45 and extrude, just make the heights. The same thing you can try doing it with this. We have done it in isometric, try doing it in axonometric. Try by drawing the plan, which is what you will see from the top, and drop it to the bottom. So, once you drop it to the bottom, you will see what this nut looks like. Try doing this at home and come back to us if you have any queries. I will try to draw this one in axonometric. This top one is the plan and this one is the front elevation, to show you how a combination would appear. So, I will first start by drawing the plan. So, let us draw this. And so, this is the plan which we got, right. So, I am erasing all the excess lines so that we have just the plan left. Okay. And now I am only going to draw the heights of this one. So, now if you see this, okay, I will also draw the dotted lines here. Whatever is in the plan, I am just drawing that. Okay. So, we will see it from the front and start giving them different heights. Let us start with this one. We have a certain height to this, or maybe I will start by drawing the central portion, which is here. So, we have to draw a semicircle here, which is what we can see. And we also have another semicircle coming parallel to this, which is here. Okay. So, this is what we saw. All right. Now, the same thing is at the back, but right now we are not drawing it. Now, we know that this point, which is here, is at a distance of this much. So, I just erase it. and this is where approximately it will come. So, we will see a line here, which is this line, Now, we are also seeing this line here, which means that the point here, which is right here, to this point is going to be joined by a curve which is parallel to this curve, which is what we will get, and we will also get the same thing here, but I am just drawing it in dotted. We could also draw the same thing, the same curve at the back. And there will be a dotted one inside. So, this is what we got here. Now, this is a straight line at the same level up to this point, and now we got this line in the bottom here, which is this. So, I just brought it down by the same height here. Okay. Now, there is this, okay, so there was also, so at this point is the center of the circle at the same level here. So, probably the dimensions are slightly skewed. Okay. So, this was to come down here, not. So, we have a circle coming here, which is what we saw. And with the same center, we also have a circle, but at this height we also have a line which is horizontal. Okay. So, with this center and this as the radius, we can also take the same distance from here. We will draw the remaining part of the bigger circle. This is what we will see when we are seeing the axonometric of this drawing. Exactly the same thing we can draw at the back, which will not be visible, but we will draw the bigger circle here. This is what we get, and we will join this, which is the tangent, and then this becomes a straight line which will be parallel to this. So, we will not be seeing this, and there will be at this level there will be a circle here, and this one will go back up like this and will be joined with this. So, this is not going to be seen, but this is what we will see in the front coming. This is all hidden. Now, this one here is going to be joined tangentially. So, it will, this would actually come parallel. So, if you draw the tangent here, this is what you are going to see coming parallel. So, this basic which we learned for isometric continues to be there for axonometric, where the parallel lines will continue to remain parallel no matter what, and the ones which are not parallel will have to be derived. So, this is what we see when we are seeing it from this side, and you can accordingly exactly in the same manner draw the other side of it. So, what I can draw is I can raise this, which is this height at this point, or I could also arrive at this point in the elevation, which is this line which I drew in the plan, take the height which is here. So, I just took the height here, draw a parallel line, which is what we will see if we were to see. So, this is going to be at the back and we will not really see it. We can just raise, we can just increase the height, we will arrive at the radius, which is where it has to be from this level. So, we assume the plan to be at this level. So, we will raise the same height here, which is this, the same height here, and if I have to draw it like this, same height and another circle, parallel, raise it again, parallel line, continue it, and ideally it should be coming here, and this point will be parallel to this curve at the back. It will not be seen, but it will go parallel, and the same thing we will do here. We will draw straight and then the curve which was coming. Now, I will erase all the excess lines and you will see that we have arrived at what would actually be seen. So, I am just removing all the excess lines for us to see the actual object. Now, if you can make sense of this object, I would erase some more lines here. Which was our original plan. Okay. This is what the final axonometric of this object for which the orthographic projections are given will look like. This is what you will see in the front. In the back, we have this, the tangent coming, joining this. There is a hidden part going behind. Now, here we have tangent joining the semicircular part, straight line. That is approximately how this object will look like, and you can very clearly see that we have been able to draw it simply starting from the plan and just taking the heights. So, in case of circles, we arrived at the centers of the circle where also establishing where the diameter and the radius is going to be. So, knowing how the circle is going to look like. In case of circles, we have to establish where the center is and then define its boundaries, and you can clearly simply draw the circular planes. And for the rest of the ones, we derived the heights at which. So, for example, in this case, we derived where this point is going to be, and this was the other point, and we simply understood that this is going to be the curve which is parallel to the original curve, the actual curve of the main object. And that is how you could derive the axonometric view simply from this given orthographic projection. We did not even have to measure. The simple thing you will, when you draw it at home, is to just rotate it and start giving it certain heights, whatever the drawing is. I hope you have been following it. There are certain other examples which I want you to pursue, start drawing at home, and in case there is any problem, please come back. So, there is a hemisphere on which a square base pyramid is kept. So, try drawing this at home. There is another one which we have attempted in isometric view, where we have a hexagonal prism over which a hemisphere is kept. So, looking at the dimensions, whatever we have, try drawing this one at your home in your sheets physically. And if you wish, you can also send us the snapshots of these different drawings which you are attempting at home, and you can ask for any query or any issue that you are facing while drawing them. So, thank you very much for attending my course. This is the end of this course, and it was the last lecture. I hope you have been able to follow through the course, and with this course you have been able to clearly understand how to convert the orthographic drawings into isometric and axonometric drawings. But for now you can follow part 1 and part 2 to cover all the orthographic and isometric axonometric which has been covered so far. So thank you very much for joining my course. Have a great learning time, and for any query you can always come back to us. Thank you and bye-bye.